Hello everyone and welcome once again to my channel Cam Science. And here I am again with another topic of quantitative chemistry, or you can say mole concept, that is molecular formula, empirical formula and percentage by mass. In this video, we are going to learn about what is molecular formula and empirical formula. We are going to learn to calculate the percentage by mass, and we will be also calculating the empirical formula and molecular formula in this video. So let's start with the molecular formula and understand what is molecular formula. Let's take an example of such a compound where we can see that there are carbon and hydrogen present in this molecule. To see what is a molecular formula, let's understand that how do we find out the molecular formula? By looking at the types of atoms present and number of atoms present. For example, here if we have 2 carbon, then we are going to write C2 in the molecular formula. And how many hydrogen are present? We have 1, 2, 3, 4, 5 and 6 hydrogen. So we are going to write H6. So the molecular formula of this compound is C2H6, as it contains 2 carbon and 6 hydrogen in its molecule. Now let's see another example where we have some more atoms in it. Say here we have 2 carbon. So we write C2. Then we have 1, 2, 3, 4, 5, 6 hydrogen. So again we write H6, and then next we have 1 O. So then we write the molecular formula as C2H6O. Here is one more example here again in which we have oxygen and hydrogen. Now let's count how many oxygen and hydrogen we have. We have 2 hydrogen and 2 oxygen. So our molecular formula is H2O2. So we can say that molecular formula is very simple thing where we just write the number of atoms of each element present in a compound or a molecule. Now let's understand the difference between molecular formula and empirical formula. Now what is a molecular formula? We have already seen that it shows the actual number of atoms that combine to form a molecule. That is how many atoms, different types of atoms are present in a molecule, that is presented by molecular formula. But what is empirical formula? Empirical formula just shows the simplest ratio in which atoms combine. Now let's understand what do we mean by this. And also let's understand the difference between the molecular formula and empirical formula with some examples. Suppose we have C2H6 as our molecular formula. Then what is the empirical formula for it? Now when we say empirical formula is the simplest ratio, so we need to find a highest common divisor for this compound, which is 2 in our case. So the empirical formula will be CH3 because we are dividing the whole molecule by 2, which gives us the carbon and hydrogen as CH3. The simplest ratio of carbon to hydrogen is 1:3. So empirical formula turns out to be CH3. Let's take another example of molecule C2H6O. Now we don't have any common highest divisor, maximum divisor for this molecule because oxygen here is just 1. So the empirical formula for this compound will turn out to be the same. That's no difference between the molecular formula and empirical formula. Taking the example of H2O2, that is hydrogen peroxide, again the maximum common factor for hydrogen and oxygen is again 2. So the empirical formula should be HO. Say another example, C6H6, which is benzene. So here the highest common factor is 6. So the empirical formula should be CH because it is in the ratio of 1:1. So dividing both by the highest common factor 6, we get the empirical formula CH. Next, P4O10, that is phosphorus oxide. Here the highest common factor is 2. So our empirical formula should be 2O5. So now we can see that we are dividing all the molecular formula by some common number which is different for each of the molecule. Dividing this number with the molecular formula, we get the empirical formula. Now, in short, we can write that we are multiplying the empirical formula with some number, say n, to get the molecular formula. So, in short, we can get empirical formula from molecular formula, and from empirical formula, we can get back the molecular formula if we can find this common number n which can be multiplied by empirical formula to get the molecular formula. Now let's see that what do we mean by this number n. Here in our case, n is 2, means if we divide the molecular formula by 2, we get empirical formula, that is CH3. But if we multiply the empirical formula with 2, we get back the molecular formula. So if we take next example, here in our case n is equal to 1 because we don't have any highest common factor. But for the next example, hydrogen peroxide, again n is equal to 2 because if we multiply the whole empirical formula by 2, we get back the molecular formula. Next, here our n is 6. So multiplying CH empirical formula with n, that is 6, we get back the molecular formula. And same in the case of the phosphorus oxide also, where again n is equal to 2. So we get back the molecular formula. So I hope now we can understand that getting empirical formula from the molecular formula and from the empirical formula to molecular formula is a crisscross method. So now let's understand the difference between the molecular formula and empirical formula. Again, from the molecular formula, we can know that what are the types of atoms or elements present in the molecule, and we can also know the number of each type of atoms present in the molecule. But from the empirical formula, we get the types of atoms and elements present in the molecule as like molecular formula, but next we don't get the number of each type of atoms, but we get the ratio of each types of atoms which are present in the molecule. And we can easily calculate empirical formula if we have some data about the molecule or the compound with us. But before that, let's see what is percentage by mass and how to calculate it. Percentage by mass tells us how much of each element is present in a compound as a percentage of the total mass. Now let's see what is this by understanding its formula. Now what is the formula of percentage by mass? Now in a compound, there may be 2 or more elements present. So to calculate the percentage by mass of an element, we need to sum the relative atomic mass of that element in a compound and divide it by the relative molecular mass of that compound, multiplying it by 100. This is the formula of calculating percentage by mass, and as we have seen in our earlier video that we had seen 2 of the formulas. So this is going to be your third formula which you can note down for this chapter. And then let's take an example of how to calculate the percentage by mass. Example 1. Calculate the percentage of oxygen in sulfur dioxide. So for it, we should know the formula of sulfur dioxide, which is SO2. Now in SO2, that is sulfur dioxide, we have 2 oxygen atoms. So according to the formula, if we sum the relative atomic mass of oxygen in this compound, that is sulfur dioxide, then to calculate the percentage by mass, we should have 2 into the relative atomic mass of oxygen, which is 16. Now it says divide by the relative molecular mass of compound. Now molecular mass of compound where we have sulfur whose atomic mass is 32 plus we have 2 oxygen. So here again it is 2 multiplied by 16 and the formula says multiply by 100, for which we get the answer 50%. So the percentage by mass of oxygen in sulfur dioxide is 50%. Let's see example number 2. It says calculate the percentage by mass of iron in iron 3 oxide. Again, we need to know the formula of iron 3 oxide, which is Fe2O3. Again, by the formula of percentage by mass, we should sum up the relative atomic mass of iron to calculate its percentage. So atomic mass of iron is 56, and as we have 2 iron atoms, we need to multiply 56 by 2. Divide by the relative molecular mass of the compound. So again, the molecular mass of compound can be obtained by summing up the relative atomic mass of all the atoms. So here we have the relative molecular mass multiplied by 100. And here we get the answer of 70%. So percentage by mass of iron in iron 3 oxide is 70%. Here in the same question, we can calculate the percentage by mass of oxygen also in the same formula, but then in that case here in the numerator, we should have the relative atomic mass of oxygen. So what are we going to do is that if we are supposed to calculate the percentage by mass of oxygen, then in the numerator we will get 3 into 16 to get the relative atomic mass of oxygen. Again divide by the same thing and multiply by 100. So whatever answer we get, that will be the percentage by mass of oxygen. So I hope you are very clear with what is percentage by mass by now. Now how to calculate the empirical formula. Suppose if we have the percentage by mass of all the elements present in a compound, then we can calculate the empirical formula. Now let's see how can we do that with the help of an example. It says a compound contained 50% of sulfur and 50% of oxygen. Calculate its empirical formula. Now how are we going to calculate the empirical formula? We are first going to write both the elements separately like this, and then let's write the percentage of both the elements below it. That is, sulfur is also 50% and oxygen is also 50%. So I'm writing percentage here. Next step is dividing it by the relative atomic mass of that elements. So dividing it by the relative atomic mass of sulfur, which is 32, and for oxygen it is 16. So here we get 1.56, and for oxygen we get 3.13. Now what are we going to do next is that out of the two numbers we are going to find out the smallest one. So in our case we have 1.56, which is smaller. So we are going to divide both the numbers by this smaller number to get the ratio of both these numbers, or you can see the ratio of both the elements. Now here we get the answer 1 and here we get the answer 2. So in this case sulfur is 1 and oxygen is 2. So our empirical formula is SO2. So this is how we get the empirical formula if we know the percentage by mass of each element present in a compound. What we had done is that we had divided the percentage by mass by the relative atomic mass, and then we get the simplest ratio by dividing both the numbers by the smallest number out of it. And then we get the empirical formula. Let's understand with one more example here. A compound contains 29.75 gram tin and 35.5 gram of chlorine. Calculate the empirical formula. Now here we can see that we don't have percentage by mass, but we have directly the mass. That will also do, and we can calculate the empirical formula by the same method as we had done it in the earlier example. So let's start by writing the two elements in series, and with the same method, let's write its mass below each element. So for tin it is 29.75 gram and for chlorine it is 35.5 gram. And now we are going to divide it by its relative atomic mass, which is 119 for tin and for chlorine it is 35.5. So the first step is to divide by its relative atomic mass. And now as we can see that what we have done is divided the mass by relative atomic mass. So this is the formula for number of moles as we have seen in our earlier video. The number of moles is equal to mass divided by its relative atomic mass. So in short here we are finding the number of moles of each element present in the compound. Means in our earlier example also by dividing with the relative atomic mass here we had found the moles. So in this example, the moles of tin is 0.25 moles and for chlorine it is 1. Now the smallest number is 0.25. So we are going to divide both the number by 0.25. Now here we get the answer 1 and here we get the answer 4. So our empirical formula is tin should be 1. So SN 1 and chlorine should be 4. So Cl4. So empirical formula of tin chloride is SnCl4. So this is how we can calculate empirical formula either by the percentage by mass of a given element in a compound, or if we know the mass of that element in the compound, we can both ways find the empirical formula by the same method. That is first dividing the mass by the relative atomic mass and then finding the ratio by dividing with the smallest number to get the empirical formula. Next, let's see how to calculate the molecular formula from the empirical formula. Now in our earlier part of the video, here we had seen that if we can calculate the N, then from the empirical formula we can calculate the molecular formula. So our main aim now is to find out the N so that we can calculate the molecular formula from empirical formula. So let's understand this with the help of an example. A compound has the empirical formula CH2. So here we already know the empirical formula. If it is not given, then we can calculate the empirical formula as we had seen earlier from some other data. And from this, its relative formula mass is 84. That is also given. Now we need to calculate the molecular formula. Now here the main part is how to calculate the N. Now we can do that by dividing the molecular formula, that is MR of this compound, with the empirical mass of the compound. So molecular mass is already given in the question, but we need to calculate the empirical mass. Now we know the empirical formula, which is here CH2. So what is its mass is, for carbon the relative atomic mass is 12 and for hydrogen, we need to add. So for hydrogen we have 2. So the empirical mass turns out to be 14. So if we use that here, we need to divide 84, which is the relative formula mass, divide by 14, which is the empirical mass. So dividing the molecular mass by empirical mass we get the number n, which in our case is 6. So to calculate the molecular formula, we need to multiply the empirical formula with n. So here we have CH2 and the n calculated is 6. So the molecular formula turns out to be C6H12. So what we need to know is both the molecular mass, that is our relative formula mass, and we also need to know the empirical mass, which we can calculate from the empirical formula here. If we divide both the numbers, we get the number n, from which we can calculate the molecular formula. So we can see that this can turn out to be the formula to calculate the molecular formula from empirical formula. And I hope you would have understood this basics in this video about the empirical formula, molecular formula, and keep watching for the next topics of the quantitative chemistry. And if you have liked my video, don't forget to subscribe and ring the bell.